In this video, we're going to answer questions 2 and 3 of the first exam paper. What do questions 2 and 3 normally cover in our matric final exam paper? Well, number patterns, so linear, quadratic, and exponential, and of course, sequences and series, arithmetic and geometric, which are the same essentially as linear and exponential number patterns. So all exam questions are from the DBE November 2022 paper 1 exam, and you can download these from the website or from MathShop as well. So question 2. Question 2.1 says the first term of a geometric series is 14 and the sixth term is 448. Calculate the value of the constant ratio. So we can see that A is 14 and term 6, which can be written as A times R to the power of 6 minus 1 is equal to 448. Now we already have A, it's given to us as 14, so we can substitute that in. And so we can say that 14 times R to the power of 5 is equal to 448. Now we get R by itself by dividing both sides by 14. So we have R to the power of 5 is equal to 32. This you can just pop into your calculator very quickly, which I have already done. Now the fifth root of R, so we take roots of both sides, and we take the fifth root so that R is by itself. And I'm going to show you how to do this on the calculator quickly. So to do that, what we would then do is say 5, second function, and this button here, you'll see it says in orange X with a root. Okay, so that puts your 5 as your X. We type in 32 and we get equals, which is 2. So back here, where I've lost my question, that's good. So we had R to the power of 5 is equal to 32, just to follow on from that. And so we took the fifth root, and what we got in answer to that was R is equal to 2. And that is what the question has asked us for. So just very straightforward, basic algebraic manipulation. The next part of the question says, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum. So we know that the sum is a exponential sum. So we're going to have Sn, and if you look at your formula sheet, you'll find this formula, A1 or R to the power of n. We normally use R minus 1 when your constant value is bigger than 1. Okay, so R to the n minus 1 all over R minus 1. So our sum is 114,674. And we substitute in our values, so it's sorry, it's not A, it is 14. And R is 2, so it's 2 to the power, and we're looking for n minus 1 over 2 minus 1, which is actually just 1, and so that basically drops, because when something is a fraction of 1, it just is actually that number. So now we have 114,674 is equal to 14 times 2n minus 1. Right, now we get rid of the 14, so we divide both sides by 14. And again, I have done the calculation already, and the answer to that is 8191 is equal to 2n minus 1. Now we take 1 to the other side and we add it, minus over the equal sign becomes plus, so we have 8192 is equal to 2n. Now, this is actually a log question, or in other words, what base of 2 is 8192? So what we'll do is, there's two options. You can do it solving it for the log. In other words, you say log base 2 8192 is equal to n on your calculator, and that will give you an answer. Or you can prime factorize this answer. So we'll do both of them just so that you can see. Here we go. So we're going to say 8192 equals, and then we'll say second function and p fact, and you'll see that we get 2 to the power of 13. In other words, n is equal to 13. The other alternative answer, or the other way to do it, is to say second function log. Our base is 2, our answer is 8192, and that will give us an n value of 13. So both ways are correct. Now the question actually asks us, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum. So we got a total of 13 terms for the entire series. So what we're then going to do is we're going to say 13 minus 6 is 7. So our final answer is actually 7. 2.1.3 says, if the first term of another series is 448 and the sixth term is 14, so in other words, your terms are getting smaller, calculate the sum to infinity of the new series. So here we have A is equal to 448 and term 6 is equal to 14. And by intuition, we're going to guess that R would be the inverse of the first R value that we got. But let's prove it quickly. So we know that A, R to the power of 5 is equal to 14, right? And A is 448 times R to the 5 is equal to 14. And then R to the 5 is equal to 1 over 32. And we know that the fifth root of 32 is 2. So R is equal to 1 over 2, which is what we guessed. Now it says calculate the sum to infinity. So don't forget that part. That's what they're actually asking you for. So sum to infinity is A over 1 minus R. I'm just going to do it on the side here because I've run out of space. So A, we said, is 448 over 1 minus a half. So in other words, 448 times, 1 minus a half is a half. And how many halves are in 448? Or in other words, double 448. And your answer will be 896. Okay, so again, you can just plug that into the calculator to find your final answer. Now, 2.2 says, if K is equal to, if the sum of starting P at 0 and ending at K of this function here, 1/3 P plus 1/6 is equal to 20 and 1/6, determine the value of K. In other words, when does the series end? So first we need to find term 1. So term 1 is going to be 1/3 P as, so P will be 0, right? Because we're starting at 0, plus 1/6. In other words, 0 times a third is 0. So term 1 is equal to 1/6. Term 2, P is equal to 1. So we'll have 1/3 times 1 plus 1/6, and that will give us half. Then term 3, P will be 2. So we'll have 1/3 times 2 plus 1/6, and that will give us 5/6. And here I'm just going to convert this into 6. So that'll be 1/3 over 6. Okay, so we can see that our A value is 1 over 6. And we can see that we're adding a constant ratio or a constant difference of 2 over 6. Can you see that? 1 plus 2 is 3, and 3 plus 2 is 5. Okay. So now, I'm just going to do the sum on the side here. So we've got Sn is equal to, and this, again, formula is on your formula sheet. So we've got 2a plus n minus 1 times d, because we are using, this is a plus, because we are using a linear or arithmetic sequence. Okay, so now it says the sum of n is, we know that from what it's given us, which is 20 and 1/6, right? We have n, which we don't know, that's actually k, which is what we're looking for, over 2. Our a value is 1/6, plus k is what we're looking for, and our difference is 2/6. Right. So, to simplify things, I'm just going to multiply by 2 on the other side to get rid of this 2 over here. So this will be 40 and 2/6, or 1/3. And then we'll have k, and then let's simplify inside. So this will be 2/6 plus 2/6 k minus 2/6, right? We're multiplying the minus 1. So it's k times 2/6 and minus 1 times 2/6, which gives us this much here. So we're going to simplify again. So we have 40 and 1/3 is equal to k times, and here we've got 2/6 minus 2/6. So that actually cancels, and we're left with just 2/6 times k. And if we simplify that, we get 40 and 1/3 is equal to 2/6 times k squared. Right, so now we need to get rid of that 2/6. So we're going to multiply 40 and 1/3 by 6/2, or essentially 3. And that will give us a total of 121 is equal to k squared, and the square root of 121 and k squared means that k is equal to 11. Now remember that we started p at 0, so in fact k is not equal to 11, but rather to 10. Remember that we don't find negative answers when dealing with number patterns and the place value of a number pattern. So we only work with the positive solution. All right, on to question 3. So question 3 says, it is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9. So we even knew most of it. And the first term of the first differences is 7. So show that b is equal to 4. Now that's quite an interesting question setup. Okay, and it feels like maybe there's not quite enough information. So what we're going to do is we're going to write down the information that we have. So we have Tn is equal to n squared plus bn plus 9. Right, and we have then term 1 is equal to 1 squared, which is 1, plus b times 1, which is just b, plus 9, which if we simplify gives us 10 plus b, right? And if we do the same thing for term 2, we'll get 2 squared, which is equal to 4, plus 2b plus 9. And if we simplify that, we get 13 plus 2b. Now we want the first term difference, right? In other words, we're just going to subtract these two from each other. That will give us the first term of the first difference. So we're going to say 13 plus 2b minus 10 minus b, right, is equal to, and they've given us 7, so we're going to put 7 there. So if we simplify further, 13 plus 2b minus 10 minus b. If we take 13 minus 10, we get 3. So we'll have 7 is equal to 3. 2b minus b is just 1. And we'll take 3 to the other side. 7 minus 3 is 4, equal to b. And so we've actually proved what they've asked us to prove. The next question says, determine the value of the 60th term of this number pattern. So we've just found, we've been given that Tn is equal to n squared plus b, which we now know to be 4n plus 9, sorry. And now we want to find the 60th term. So this is just a simple substitution. Substitute in 60, put in 60 here, squared, plus 4 times 60 plus 9. Now, 6 times 6 is 36, and 0 and 0, plus 4 times 6 is 24, add a 0, plus 9. So our final total will be 3849. Don't worry, I didn't do it in my head. I used my calculator. See why calculators are important. All right, so there's that question. Pretty straightforward, right? And then the next question says, determine the general term for the sequence of first differences of the quadratic number pattern. Write your answer in the form TP is equal to MP plus Q. Okay, so we've got term 1, which we found to be b plus 10. So that is going to be 14, right? We found term 2 was 13 plus 2b. So that will be plus 8, will be 21, right? So now we need to find term 3. So term 3 will just substitute in n squared. It'll be 3 squared plus 4 times 3 plus 9. And that will give us 30. And term 4 will be 4 squared plus 4 times 4 plus 9 will give us 41. Right, now we need to find the first common differences, right, of the sequence. So we've got 14, 21, 30, and 41. So 21 minus 14 is 7. 30 minus 21 is 9. And 41 minus 30 is 11. So here we can see our first common difference is 7, 9, 11. And from that we can see that the difference is going to be 2 each time. Now if we put it into this format here, it's going to be, this is going back to before we used the arithmetic formula, we had a first, which was 7, plus, and your p minus 1 times 2, which is your difference, right? So if we multiply all this out, it'll be C7 plus 2p minus 2. So we'll have 5 plus 2p gives us this formula here. 3.4 says, which 2 consecutive terms in the quadratic number pattern have a first difference of 157? Now, we've just found the formula where we had TP is equal to 5 plus 2p, right? And what it's essentially telling us is that this is the term, which is 157. So we're just going to solve. Whoopsie, I wrote that very badly. That's a p. for p, right? So we're going to take 5 to the side, and that leaves us with p. 2p is equal to 152, and we divide both sides by 2, and so p is equal to 76. So that means that the two consecutive terms would be n is equal to 76 and n is equal to 77. So I hope you found this video helpful in practicing number patterns. And then remember to watch our next video on paper 1, question 4 and 5, where we will be working through functions. Remember to take a look at Maths Sharp for all of those free worksheets and get your Sharp calculator before your final exam.